So my name is Bryan Soltis. I'm a technical evangelist at Kentico, which is, anybody heard of Kentico? It's a .NET-based content management system. We also have a cloud-based content management system. You're going to see a little bit of it today. The talk is really on Azure Search, but I want you to be aware of it because you're going to see a little bit about it. I am a Microsoft Azure MVP. I have worked with Azure since before it was released. I've done a lot of work with it. I really like working with Azure. And I really like doing things people haven't done. How many people have used Azure Search? Okay, well, I'll hopefully try to tell you something. Normally, no hands go up. So I'm like, okay. Even though I'm talking to Microsoft people, they're like, what's Azure Search? I'm like, it's your product. If you don't know, Azure Search is pretty awesome. And I'll try to tell you why it's awesome. So I give talks, I go around the world, and I try to tell people that I'm from Florida. And everybody assumes Florida. Woo, I'm going to trip over that. Everybody assumes Florida, you know. But no, I live over there. So this Central Time, Florida. So I was saying it's nothing like driving 5 hours on I-10 in the same direction and still be in Florida. That's awesome. So that's where I live over there. So let's talk about Azure Search. So really, there's a lot of things when it comes to search. It's really tough to fit search into what you want to do. Because everybody wants like, oh, build a search. Oh, how do you want it to work? Oh, we want to work like Google. I was like, oh, do you have $1 billion? No. Okay, well, it's a little tough to fit the needs of everything. People, they can't find what they're looking for. That's a big problem with search. They're trying to find something. So you need to make it as easy as possible for them to find what they're looking for. And if you don't, they get really pissed off really fast. So really, the answer is Azure Search. And it's funny because I took this. It actually said like 2013 or 2012, back when Jon Stewart was still on the show. So I had to like Photoshop in the 2018. I've been using it for like a year, so it's actually close to the right date now, which I'm happy about. So really, it's all about Azure Search, and that's like one of the best things I've ever found in Azure that I worked with. That's extremely powerful, and it's very customizable, which is the main aspect of it. But basically, you have a process of you're going to have data. That data needs to be indexed by something, and then people are going to search against it. And so I'm going to show you how Azure Search can fit into this process and hopefully open your eyes to how cool it is and the things you can do with it. But you have to look at why you want to use hosted search. And really it comes down to several reasons. One, search can be very difficult to do. It can be very complex. It's going to vary from industry to industry. How people find information and how they look for it is completely different depending on the context of what you're talking about. If you're searching for books, you want to search by authors and titles. If you're searching for shoes, it might be colors or brand or sizes. So that can be very complex of how these search solutions get configured, developed, and integrated into the system and how people are going to interact with it. If you do any kind of e-commerce stuff, you know, your load may be difficult to predict. You may not know how much search horsepower that you need. And search itself can be very resource intensive in the environment that it's in. If you have a very complex search of, you know, you're grouping lots of things together and you're pulling from multiple data sources and you're scouring through that and doing maybe a full text search on your database or something, that can be very resource intensive and that could have negative impacts to the performance of your overall application. And if it doesn't work, generally people tell you that really fast because they'll be like, I can't find anything, and they'll just won't be on your site because they can't find what they're looking for. And really, it's IoT. It's really supposed to be. There's extra O right there. This is my favorite part of this presentation, is the fact that I can do this. Ooh, that is what should not be there. Someone bought me this. I was like, really? I'm like, but it's really cool. It actually comes in handy for that moment right there. So it doesn't really have to be that hard. There's an easier solution. And it really comes into Azure Search, but we have to break it down into multiple things. So the first thing we have to do is we have to talk about creating indexes. So with Azure Search, you have your data and it has to be indexed. And here's a spoiler alert. Behind all search, just about, that's available right now, is Lucene. Lucene's behind everything. Lucene runs all search. Is anyone an expert in Lucene? Has anyone ever glanced at the novel that is the Lucene documentation? I know like this much. If it's this big, I know like that much. It's like Excel. Like I can do this, but it really can do all that. And but that's what powers Azure Search. That's what powers Elasticsearch. At Kentico, we have a built-in search to our main .NET-based content management system powered by powered by Lucene. Lucene's buying everything, and I think they just figured out that that was like the best way to do it, and it's the most efficient. But it really all starts with creating the indexes. So before you can actually first you have to have the data to search. Before you can search that data, you have to tell it how you're going to interact with it, and that's where the indexes come into play. So for your indexes, that data has to be in Azure. So for Azure Search, the data has to be in Azure first, which is a big deal. Well, it's not a big deal if your data is already in Azure, because if it's in Azure, well, I'm jumping ahead to the thing I'm going to say. If it's in Azure, you can pull that data directly from wherever it is, whether it's in a what's it called today? Is it called SQL database in Azure now?
Azure SQL database.
Is that what it is now? Azure SQL database? I still say SQL Azure because that's what it was. And then it became, it was SQL Azure, then it was like Azure SQL, and then it was like SQL database, and now I think it's Azure SQL database. I don't know. This week, that's what it is. The thing about Microsoft, no matter what it is, it'll just change next week when they decide to rebrand it. But if it's already there, you can set up what's called an indexer that will go and hit that data at the schedule that you want. But if your data is not in Azure, like say it's an on-premise solution, you have to push that data up into your Azure index. So that's an important piece, and I'll kind of show you two different ways that will work. But you have the two different models. They have a .NET SDK, which you're going to see a lot of because that's what I do, is .NET. The indexes themselves, I'm pretty sure that number is still accurate. I actually haven't verified it in a little while. But you can only have 1,000 fields in one index. But for each field, you basically tell it how you're going to interact with that data of that field. Whether it's the key, the primary key for the records, is it searchable? Are you going to be able to filter on it? Can you sort on it? Will it have a suggestion capability, meaning you'll be able to get suggestions from that field? Are you going to retrieve it when you bring it back, and then are there any text analyzers that are going to be applied to that specific field? Or is the field a synonym, which I'll show you all this fun stuff. But it really all starts with defining the index, and the thing I like to stress here is it's important to know that you can have the same data but multiple indexes on that data, because in some indexes you maybe will combine fields to be a retrievable value, in other ones you won't. And if that affects how you're going to interact with the index, you potentially could have multiple indexes on the same data, depending on how the field definition, the index definition itself is configured. So, when you search data, as of right now, they still only support a single index at a time. You can't join indexes, but it uses your field data. Your field data types are all OData, so you have like integer and Boolean and datetime and there's some other ones, but it does full text query matching on those fields to find the value that you're looking for on the fields that you marked are searchable when you define the index. And you can do like search asterisk, you can do starts with, ends with, you can kind of do some different stuff there in regards to searching for the data. And there's a lot of configuration that you can do around scoring. That's really where a lot of the power of Azure comes into play, is that you can manipulate how Azure Search is going to give you the results based on scoring profiles that you define. And in an example of, like, let's say you're searching for a book, you might have author, description, and title. If someone's looking for a specific author, you would want to give them results that are most relevant by, let's say the author is, those are more valuable, so if it finds the results in the author field, let's make those the top ones that do. But if they want the title, you're going to list those as the highest thing. So basically it comes into the sorting capabilities of how it returns the data to them, but you can assign your own scoring profiles to the data as they are looking for it. And that could be, if it's found in this field, let's weight these higher so that they're more relevant, so they have a higher score. But you can even do custom functions inside of there in which you pass information in, and it calculates it based on what's in the field to determine if its score is going to be higher or not. So you can really do a lot of stuff with a scoring profile. So I have several examples I'll show you here momentarily. But that's one of the most powerful aspects of Azure Search in my opinion. And there's a .NET SDK, but it really is just a wrapper for the REST API. And the reason I make note of that is they often update the REST API, but the SDK is a little bit later. It could be months later. I think it was about 2 or 3 months ago they released what's called synonym mapping, which you can basically, if you have a value that you know in one field, you can say these are synonyms for that value, and it will return results even though they don't match what the user searched for, but they're synonyms for it. My example will explain it a lot better. That's been in the REST API for over a year, but it just got released in the SDK maybe 2 months ago. So it's always lagging behind there, but if you really like to work with REST APIs, you can just hit it directly to do that. A few more kind of, let's say, past the table of contents kind of thing. You can do facets. So like in Google, where you have all the nice little facets of price and brand and color and all those things. You can have your own facets, but you have to say which fields are facetable when you create your index, so that becomes important. And then you can have multiple ratings inside those facets to say which ones have precedence over the others. And then the facets lead to filtering. So you can, if someone has a facet and let's say they're looking for shoes, and you say, okay, let's show me only the Adidas, then you're filtering then your results on only Adidas, but you can only filter on a field that was facetable. So this is, I told you, defining the index is like the most important thing because that's going to determine how it's going to function, how someone's going to interact with the actual index itself. I kind of talked about the scoring profiles. What's really cool is it has geolocation, or not geolocation, it has location-based scoring built into it. So you can have geography points as part of your index, and then you can pass in, like, say, coordinates for something, and it will figure out what's closest to that. Again, the example will be much more exciting. Hit highlighting, which is funny because that's like the simplest thing to do, but that's the thing people like the most. You can say highlight the value that someone searched for in the results, and you don't have to parse those results. It will already be designated by whatever you say. It's called a pre-tag and a post-tag, and you can put whatever you want to. Basically, in the results that it gives back to you, it will put whatever you say as the pre-tag, whatever you say as the post-tag around it. So in my case, I use like a span with a specific class defined on it, like highlight. And then in the results that come back to me, it will be like text, span, whatever they found, close span, and then the rest of the text. So I can just throw it up on the page. I don't have to parse that in any way. So it's a really kind of cool feature, and one that's not incredibly exciting, but it's the easiest to implement, and people really like it. I talked about the synonym mapping. Another feature that they just kind of rolled out like 2 months ago was autocomplete. So they've always had the concept of suggestions. So you can take what someone's typing and basically look into the data, into a specific field that you marked as have a suggestible, and it will say these are possible matches to what they're trying to find. Autocomplete is very similar, but it will find exactly it will find ones that match exactly how they type. So you can do like an autocomplete thing coming up as they type down. So they just released that maybe 2 or 3 months ago, the autocomplete. So that was a pretty cool thing. So enough of that boring stuff. Let's get to the real stuff. All right. Let me start with this real quick. I didn't sign into our system to show you. I need you to see where the data is. So I do use Azure Search on my own website, but my demo code is a little bit funnier. But I will show you my code as well. But I've been doing this a little while, and I've talked all around the world, and it's difficult to find something that is universal to everybody. The Simpsons are universal to everybody. Everybody loves The Simpsons. So my data is Simpsons quotes. So I told you this is Kentico Cloud. This is our kind of cloud-based content management system, or the content repository, and this is where I have all my data configured inside of here. So in here I have a bunch of quotes, and for each quote I have some data. So I have author. So this is Grandpa Simpson. I have the text of whatever it is he said. And then I have this latitude and longitude. That's really just for demo purposes. It's just so I can show the geolocation. I just want you to understand the data structure that I have. So I have this author, text, and then latitude and longitude, which all the latitude and longitudes are just random. I think I pulled all the US capitals and they just assigned, or maybe I picked random ones, I don't know. But they're just so I can show you the range, or the searching by location. Yes?
Suggestion, you should just use all the Springfields.
That would be a good idea, but I have over like 100 quotes, so I would run out quickly. But I think there's like, I remember reading something about it. There's like 30 or something that they've referenced. Like some are on the coast, and some are in the mountains, and some are everywhere else.
Someone posted an optimal driving route between all of them on Reddit.
I swear to God, people have way too much time on their hands to do things like that. That's awesome. Okay, so this is all my text and my quotes. And so what I have in my site is I have, and I'm just going to run it here. So I have a demo page in my site. It's my very awesome site. You can tell I'm a developer, not a designer. There's a subtle gradient from right to left, from left to right. Took me a while to figure that out. Anyway, so I have a demo search page, and in my demo search, I'm going to step through each one of these processes so you can kind of see how it all works. So I'm going to take it from creating the index to loading the index, because again, my data is not in Azure, it's in Kentico Cloud, so I have to bring it into my Azure Search environment. And then I have to delete the index, which I'll use to clean up. So the first thing I want to show you is creating the index. And so I have a helper class in my application, and let me walk you through each part of this. So the first step is to create the index itself, and there's several pieces to it, in which I basically connect to the SDK. I'm going to use the SDK to connect to the Azure Search service. And the first thing I do is I set up a synonym map. The synonym map is not on the index level, it's on the search service level. So your search service could have multiple indexes inside of it, which will come into play when you decide to pay for Azure Search. You would want to do that. First thing I'm going to set up a synonym map. And because I have Simpson quotes, I decided to make a synonym map called Hank Azaria synonym map. And basically, these are all synonyms. So when someone searches for, let's say, Ralph Wiggum, I want to return all the other voices that Hank Azaria does. So I've made a synonym map for this that I map out all the different possibilities. I don't think there's any limit to the number of synonym maps. You can make as many as you like. The only thing that's important is this name, because when you get to the definition, this is one of the most important pieces of Azure Search, and this is where you define the index structure. So I have like quote ID, it's a string, it's the key, it's not searchable, filterable, because I don't care, because it's the key. I don't care about that, that's just the identifier. But what I do care about is this is searchable, that's searchable. The location is not searchable, but it is returnable, which it's over to the right. I'm going to trip over that, I'm sure. I've already done it several times. But if you notice here on the author level, let me just highlight it, so that way it'll show up. You'll see I've said it's retrievable, and I've also added the synonym map as that synonym map. So that means I can actually now have synonyms for the quote author, and I can use that as part of my searching if I do that. Okay? But this is where you define, and this could be completely different depending on how your data is or how you're going to interact with it. This is just how mine is set up for now. Then I have what's called suggesters. And again, that is to try to suggest to people what they may be looking for. I want to, as you type it, I want to go get possible suggestions for what it is you might be looking for. So you have to define the name of it and then tell it what field is going to be a suggester. So in this case, the quote author is the suggester field as well. The scoring profiles, I have two very basic ones, and then the third one's a little bit more complex because it deals with the distance scoring. But the first one is just called for the quote author, and basically I'm going to give those 5 more points. If it finds the value in quote author, then those are going to be ranked higher. I have another one that's quote text, and if it finds the value that you're looking for in that field, it's going to rank those higher. And this is how you can have multiple fields, and you can have certain combinations of scoring or whatever it is you want to do. You can totally customize it however you need to do it. Those are just two. This is like the very basic scoring profile possible. This one's a little bit more complex though. It's a distance scoring function. So it's not a custom function because distance scoring is already in there. But I'm basically telling it on the quote location field, rank those higher, and I'm going to pass in a location, and it's going to figure out which ones are closest to that. And the closer they are to the point I pass in, the higher they'll be ranked. So, and then everything just gets loaded up into the definition object, and this one calls what creates that index. Okay. So over here, this is my search service, and I'll show you. I have one index in there, which is my real index, But I don't have anything else in there so far. That's my real index that's inside of there. So on my very exciting demo site, I'm going to create the index. Come on, interwebs. There we go. So now, one thing about Azure that kind of bugs me, sometimes it refreshes on itself, sometimes there's a refresh button, sometimes not at all. So I don't know why. I've told them that. It's like the biggest feedback I gave them. So now you see I have a quote index, but it's not loaded with any data. I've only defined the index. And you really only define the index once. Then you use the data over time. But this is where you can see the different fields, and you can see how I've marked them. And if you want to do this in the portal, you absolutely can make it by hand in the portal as well. But this is where you can basically manipulate the structure of that if you need to.
Can you visualize the synonym map too?
I don't know if you can see that through the portal. I don't.
Because it looked like the name of your synonym map was different than the text you passed into that object when you were creating the looks like you're missing a dash. Hank Zygra dash synonym map in the object, and then Hank Zygra no dash.
Holy cow. Thanks. Sweet. Nothing like finding bugs in my code. I'm doing it. So this is what I'm going to show you. You can delete the index really easily right here. You can, bam, it just goes away. I have to recompile it real quick. It only takes a second. It's .NET Core. It's fast. All right, so let's, I don't know if that deletes the synonym map, though. Here's the delete if you want to see it. That's create. That's the load. There's delete index. It's not exciting. It just deletes it. So, but it doesn't delete the other one. But it doesn't matter. I don't care if that other synonym map's there. Wow. Who knows how long I have not done it. Did I even spell Hankazaria right? I don't think I didn't. Did I? Man, I screwed everything up. There we go. Nothing like trying to type at an angle during your presentation. Fixing code that someone pointed out during your presentation.
What's the worst that could happen?
At least I'm not going up against John Papa. All right. So let me launch that again. Okay. Maybe that's why that demo hasn't worked very well lately. I have a lot of EXEs that I'm not dealing with. Those are just warnings. They're not errors. It's fine. It's going to load. It's fine.
I'm just
All right.
passionate about code.
That's right. So we just started, my wife and I just started watching Silicon Valley. Sorry, we're a little late to that game. And we're like, don't tell me anything. We're almost finished with season 3. But there was the whole episode. Does everybody watch it? Okay. The whole episode with the tabs versus spaces. And my wife just didn't get it. I'm like, what kind of animal would use spaces? Like, I didn't even understand. Like, maybe that's like a non-Windows.
That's it. I'm leaving.
Okay. All right, so let's pretend like the last 3 minutes didn't happen. And so here's my index again. But I don't know if you can see the synonym map inside of here. I think I've looked, but I don't know if you can see it inside of here yet. As it is, it's just not on the SDK. I've always had to use straight REST API calls to create that synonym map. And so I don't know if but it's on the service level, not the index level, so it actually would be here, but I don't see it listed anywhere, so I don't know if you can see that synonym map inside of here. But I know you can see them through the REST API. If you make calls, you can see them there. Okay, so please don't point out any more mistakes in my code, because that's really messing me up. The next piece I need to do is I need to load that index because my data is not there. So this will be dependent on where your data is. In my case, our data is in Kentico Cloud. So I'm going to use our .NET SDK. First, I'm going to connect to it. I'm going to use our .NET SDK to connect to Kentico Cloud. And I'm going to say, go get all of the quotes out of our content repository. If you had SQL, whatever, however you want to get that data, that's fine. But this is how I'm going to get it. And and I'm using .NET because that's what I like to program in. But for Kentico Cloud, we have PHP and JavaScript and TypeScript and a ton of other SDKs available. So if you don't like using .NET, that's fine. Use your own. And I pull these back, and I have to manipulate them just a little bit when I pull this data back. Because inside of Kentico Cloud, I have the latitude and longitude. But my field for my index is actually a geography point. So for each one of the objects I return back from Kentico Cloud, I'm going to create a new object called a search quote. and I'm going to create create a point out of the latitude and longitude for the quote. Those get all added to a batch, and then that batch gets uploaded. Whenever you load your data into Azure Search, you can do like update, newer update. You can do merge. You can like delete the one that's there. It all depends on the action that you use. In this case, I'm just saying upload. I'm saying it's batch.new, but there's multiple ways you can go about that when you work with a batch. This is part of the Azure Search SDK, so there's a lot of different operations you can use there instead. So all that code does is upload it. So it's going to basically use the Kentico Cloud SDK to pull the data from Kentico Cloud, manipulate a little bit, and push up into Azure Search. So if I do this, and there we go. I will tell you that this won't necessarily update. It will still say 0, but the data is there. And it takes generally about 2 minutes or so before it actually updates. And so you'll see 0, but it actually has storage size, but it doesn't know the document count is there yet. But inside of the Azure portal, you have the Search Explorer that allows you to interact with this data. And so I can search it, and voila, there's some data. So if I want to look at it and look for, let's say, grandpa, then you can see I'm actually getting data back from Azure Search. So this is the default data that will be returned. You can specify only give me back certain fields and stuff, but this is the data that I'm going to get back. So it has the score, the quote ID, the author, and then the location point, and I don't even know what that is. I don't know what that value is. I've never used it. I don't know what CRS means. So, but that's what it's going to get back for each. What's called a document in Azure Search. It's called a document. There's all these, you create an index, and then you index data, and they become documents inside of there, and this is the document that it's returning. So the next thing that I can do now is actually start searching the data. But before I search the data, I want to show you how the suggestions and the autocomplete work, because as I start typing, things will start happening, and I want you to understand what's happening there. So I have code in my JavaScript that whenever I start typing into this box, once I type more than 3 characters, it's automatically going to make a post to an action inside of my controller to do a suggest. And this is what that suggest does. It's going to connect to the search service, and then it's going to create the suggest parameters. And with the suggestions, what's really cool, Azure Search supports what's called fuzzy searching. So it will actually find suggestions even if you don't type it correctly. You can have that offer on. And so it's a really good way to kind of guide people to what you're looking for. And then I return the suggestions. And then I parse those suggestions. I'm going to put links up. So as I start typing this, if I start typing HOM, you'll see that I have these suggestions come up here. If I do like SMP, I'm seeing Homer, Grandpa, Bart, whatever. Now I'm not using fuzzy search there. So if I were to search for like BIR instead of Bart, it's not finding anything because it's not finding anything that matches that, or that could potentially match that. However, if I were to say use fuzzy search, which is just setting the flag and that value that I sent there, and I start typing BIR, you'll see I'm starting getting multiple things that it could be. It could be BAR, Barney, BUR. I have asked the product owners for Azure Search, because right now that's not configurable. You're up to however Azure Search is trying to figure out what the suggestions are. But I'm hoping in the future they give you a way to manipulate that a little bit, because even you get suggestions, but you don't get the one you thought you would get. If you're the developer making it, trying to demo it, sometimes you do a suggestion, you don't even see it. So
for example, if you set type BIR, which you can set BIT, it's not going to give you any suggestions on BIT. Is that what you're saying?
the one that comes into play is I've seen it happen. It's I thought it was Bart, which is funny. It's like BOR. I've had this show up. I thought it was Bart that did it, but I can't remember. But I've had it typed, and I'm like, I would think that it would find that, but it didn't. It wasn't one of the suggestions that came back, even though it was only one letter off. And it was finding others that were, but I don't know why that it's not finding. I thought it was Bart that did it. That's why I used that one as the demo. But I can't remember which one it is. But what I found was you can't manipulate that. You're still at the mercy of Azure Search just to give you whatever suggestions it thinks. And I would like to see that to be a little bit more configurable, but it's not there yet. So, but I can't remember the example of how to do it. I thought, like I said, I thought it was BART, but I guess I was wrong. Very similar to the autocomplete, or to the suggest is the autocomplete. It basically looks the same. You give it, you have different ways you can do autocomplete of like how you want it. Is it one word? Is it two words? How's it matching inside of there, and what search field it's looking for? And then autocomplete will actually give you actual things that match what you're typing. So in my autocomplete example, I have a typo in here for Homer. So if I do this, you'll see I'm getting home and Homer, because those are both two values that are actual suggestions that are there. So there's Grandpa. So this is how you can use the type ahead feature to give people experience. And again, I'm showing you these kind of things because this is what you build your search out of to give people the most immersive, dynamic experience possible so they can find what they're looking for. And so they just released autocomplete, and I had to kind of figure it out. I'm like, why is it not the same as suggest? Suggest is suggesting possible matches. Autocomplete is finding exact matches. So I guess there's a differentiation there behind the scenes. So let's do BART. So if I search for BART, you'll see I'm getting some results back. I need to make that a little bit bigger. Okay. Hopefully that will work okay. So these are the natural results that come back, and I have 5. And if you notice, if I do highlighting, let me show you the highlighting real quick, just because it's not that exciting. Collapse this. So this is my actual search. And there's a lot of aspects to search because there's all these different parameters you can pass to it. So the first thing is highlighting. Basically, if I check the highlighting box, it's for the values that it finds in the results. For these two fields, quote author, quote text, I'm going to wrap, if it found the value inside of there, I'm going to wrap it in this highlight tag. I have a CSS class that makes it yellow. So if I say highlight, you'll see I don't have to parse that. It's just coming back from Azure Search with it. So this is how you can get a nice experience. And I've done this talk a lot. I've done it. I don't know if I've done it here. And I've learned all these Simpson quotes, but this is by far the funniest Simpsons quote that I've ever seen. That was like by far the funniest. So, Milhouse, I love Milhouse. So that's how you can get the highlighting, and it's a real good way to have the user interact with it. The scores are always there. You may not want to show them, but if you ever do want to see them, the value is still there. Now, the scoring range is all depending on what you define, and you decide it could be 1 billion, it could be 6, I don't know, but it's all the factor that it's going to figure out. And the way the scoring works inside of Azure is the default is how often does the value that is searched for appear in the number of fields and in the order that the fields are created. Like that's the default scoring. And so you can manipulate that with scoring profiles, which I'll show you in a second. I'm going to try to show you the synonym map. So I think one of them is Mo. So if I search for Mo, yeah. So I search for Mo, but it's actually found comic book guy, Professor Fink, and then there's some down here that are Mo. Should be at least a couple. Hank Azaria does a lot of voices. So there's a Mo, okay. So, but it's actually weighting all of those the same because of that synonym map. It thinks it's the same match that's in both of them. So this is how you can kind of figure out how people can interact with a synonym map. That's a pretty broad one, but I wanted to make sure I had a lot of results when I tried to do a demo. And it would have helped to have the right synonym map name in my code. All right, one last thing I'll show you is the facets. And that is before I show you the scoring profiles. So with the facets, you can get you can break it down. And so I have a facet on let me actually show you this over here. That's the highlights, the facets. So the way the facets work is I'm just saying, show me the facets that come back on the quote author field. So in the object that comes back, I have the collection of documents that are returned, and then there's another node of that JSON that has all the facets and then the count of each one that's inside of there. If you want to see that, I believe I'm showing it, and I believe I'm printing it out. 12. Oh yeah, sweet. Okay, let me do that again. So this is the actual response that comes back. So these are all the results, and there's 5 of them. But then because I said show me facets, it'll break those down in quote author, and so I can look at each one of these and I can see that it's written small, but you can see there's 3 of those and 2 of those. So with these facets, you got multiple facets. I'm just doing it on the quote author field. You can only have a facet on a field that you said was facetable. So again, make sure you define your indexes correctly. And then once I have facets, I can then turn around and filter on just those facets by clicking on one of the facets. And then that just does a post back in which I filter it on the value that I'm passing in, which is right here, which is, if I click on one of those authors, it says, okay, where the quote author equals the value that I just clicked on. So again, I just keep making calls back to the same search client, passing different parameters along the way. All right, so let's see, do I have 20 minutes, I think? Is it till 10:45? Okay, cool. Because there's another cool thing I want to make sure I show you. The scoring profiles, it's really not that exciting. I just have the name of the scoring profile, so I'll show you the very boring ones, and then I'll show you the other one that's kind of interesting. So let me go back to BART, and nope, don't need to do that. Don't really need the facets. We'll highlight this. Okay, so by default, I told you it's gonna find the value in the number of fields, in the order that the fields are created, and it's going to rank those the highest. So inside of here, you can see BART is showing up at the top as the author, and it's not all the way down here to the bottom that it finds it under here, under the in the quote text field, because that's the default scoring profile, which just so happens to be exactly the same result as if I do my quote author field, which is going to rank it higher if it finds it in the quote author field. But that's the first field anyway, so those results really don't look any different. But if I change this to the quote text field, and I do that one, now those are ranked higher. So by using a different scoring profile, I now have that one showing up and that one showing up. And if you look at their scores, it's where it appears in the field. I really don't know the hieroglyphics that break down the exact scoring. There's a lot of documentation on it, but you can see that these scores are higher than those scores because that's found in the author field. So that's how you can manipulate the results that Azure Search is returning to the user. And these are real basic ones that just are based off of, is it in this field or this field? But I also have a quote location text. Now to do the quote location text there's a little bit of complexity there, and the index contains a geography point for each quote, a latitude and longitude. So what I have to do then is I have to figure out the distance from some point and then the radius of that distance. So what I have is I have a default latitude and longitude for the center of the US. Does anybody know about the center of the US? Has anybody ever heard the story? So this is the center of the US. There's apparently a farm in the center of the US. And an old couple lives there, and they have gotten thousands of cease and desist letters. Thousands and thousands, because people were like, well, that's where the IP's coming from. And it's like this little farm, and they're like, it's not us. But that's where default companies do. It's like in Oklahoma. You should look it up. Center of the US, there's like a little farm, and like they have gotten inundated with all these like subpoenas and stuff because people are tracing an IP back and it's setting it as the center of the US, and so therefore it's like it's coming from them, and they're like, we're farmers. So it's an interesting thing. So if I don't choose a location, I'm going to set it as that. But I have some default ones of Chicago, Denver, and those are just the latitude and longitude of those cities. But down here is where I do a little bit of magic. Not really magic. I create a geography point from the latitude and longitude I'm passing in, and then I'm adding the filter of where the geodistance of the location of the quote is the point I'm passing in, and then where it's less than the radius that I'm getting. Okay? And then it's going to order them by the distance from that location. So it's going to order them so that the closest ones are to it. So this is the kind of stuff that you can do if you have the data that you can do with Azure Search. So if I say over here, if I say, we'll do any. This is the way they're all going to show up on a map.
Those are scene queries?
It's a, what's it called? Full search? It is. It ultimately gets passed to Lucene, yes. I mean, it's not Lucene syntax. It's called full text query search. It's just like a standard. It's the standard of which happens really behind the scenes, but that actually does get passed to Lucene behind the scenes, yes. So this is the center of the US and these poor people that are there. I'm going to choose a different one just so there's a little bit variation because I played around with this, and I'm going to choose like New York City. And so now you can see that these are getting mapped. I only have 5. Let me get something a little bit bigger. Let's do Simpson instead because I want more results. So now we have lots of results. Okay, so then if I say, let's say within, I have done it internationally, so I had to change it to kilometers. But it's basically, this is the point I'm passing in, and then it's not a custom function. It really is a custom function, but it's a built-in custom function of find the distance because every quote has a quote location, so it's doing a geolocation and figuring out those are the fastest way. But I didn't have to do any of that code. I just had to make sure the latitude and longitude are in there. All that processing is done on the server. It's all done in Azure Search, not on my machine. So this is a really powerful thing, like show me the store closest to me and things like that are the results. This is a really simple, easy way to do it. Sorry. Go ahead.
Quick question. So with the geospatial things, right? You know, potentially, does it only ever support 2 attributes, like the X and Y, or do you do like? Because imagine like if you had 2 other attributes that are measurable, you might be able to measure closeness to some value of those if you weren't necessarily using for map coordinates.
I can tell you it's entirely possible to do it. You might have to make like a custom function to do it inside of your Azure Search. This is kind of the built-in one, but you do have the ability to, let me show you. Like this is kind of a built-in one, but you do have the ability to create a new scoring profile of, let's call it sample. You have to do custom work to do it, but you can make a custom function scoring profile in which you could pull in data and manipulate it however you wanted to do it, yes. That's entirely possible. I don't know where that showed up at. It will be in here now. Should be. Right down here. There it is. And then inside here, you can add a new scoring function. And you can, they used to have a custom one here. Actually, I messed with this. There's different scoring functions, but I know there's a way to do a custom function, but they changed this. I haven't looked at it recently, so unfortunately. Yeah, I'd have to look into doing that a little bit more. I've only ever done it with the geolocation points. I haven't tried to do anything on top of that. So that's a good question, though. All right, so that's how you search inside of Azure Search when you need to pull that data into it. I have another demo only because I have time to do it. I'm going to save a little bit of time for questions. But I have another data because Azure Search has the ability to search inside of files. So you can actually have Azure Search in like Azure Storage, like files in Azure Storage, and you can create an index that actually searches inside of the files themselves. It supports like Word, Excel, PDF, JavaScript, text, HTML, PowerPoints. There's like 9 or 10 different data types that it actually will support. I'm going to go ahead and create it, and then I'm going to walk you through the code. The first step is creating the data source. Well, I can show you all of it at one time. It's not that big of a deal. So the first thing you have to do is you have to create the data source. You have to tell, sorry, I jumped way down. It is right there. The first thing you do is you have to tell Azure Search where's your data at. And this is it's an Azure Blob storage, and it's over there. It's my connection string to the actual storage account where I have these files sitting. Okay. The second step is to create the index. That looks very similar to the other of creating any other kind of index. Just know that when you use Azure to search inside of files, what it does is you always have the ID. It's going to read the entire contents that it finds, and it's going to shove it all as text into one field called content. So if you have a Word document, it's going to pull all the text out of there, shove it into one field called content, and then you can now search against that like it was just anything else. But you can also add additional fields if you need to the index. In this case, I had name and path. But it has an ID. Everything else always has to have an ID, and then it has a content. Now, this is the same way, however you want to work with that index, just like the other index. You define it however you want to do it. But that's how That's how that aspect works in regards to how it interacts with the actual file inside of blob storage. The third piece is you have to say create an indexer. So you have to tell it how often should Azure Search go look at the data source, which is Azure Storage, and index that data. So in this case, I say the data source is the blob data source, and then this is the index I just created, and go do it every 5 minutes. And then you can do additional field mappings, because I added those 2 new fields for name and path. And in that case, I'm actually going to put in from the Azure blob storage file itself the storage name and the actual path to it, the actual URL to it. I'm shoving those inside of my index as well so they can be returned. If you had your data in Azure SQL, if it wasn't a file, if it was just normal data, you would just create this. You don't have to push the data in. You can just say, go get the data anytime at every interval that you want to set it, depending on how complex your data is. You may that be every minute, every hour, every day, whatever it is. In this case, I'm saying go do it every 5 minutes. And then once that's done, then you just interact with it just as a normal Azure Search, because then it is just an Azure Search index inside of your system that has data. So I'm not going to wait 5 minutes for my indexer to be created, so I'm going to go run it manually, and then hopefully it won't take too long. We'll see. That hasn't popped up yet. Come on. We'll see what happens. While that's there, let me refresh over here. You're going to see a third index pop up here. And, oh, I probably shouldn't do that. That's the mic. There's my blob index. You can see that there's a data source down here created for my Azure Search, or my Azure Storage account. I'm not digging into the details full much because I only have 9 more minutes, and I want to make sure I handle any other questions. But this is the actual data source that was the connection string to my Azure Storage account. This is what's in that storage account right here. There are 3 very exciting blogs, and they're just Word documents. That's what's inside of there. That's what it's going to index. And let me go force the indexer to run, because it's certainly not going to run yet. So, because it hasn't never been run. So I'm going to run that. It'll take it about 30 seconds to run or so. What's really interesting about this is, again, it can parse through all these different data types and pull that information out. But then it's just data to Azure Search. So then you can do scoring profiles and functions on it. You can do whatever you want to, because the data is actually already in the Azure Search service now, and you can use it just as you would any other kind of data. Just know that it's going to pull the entire contents and shove them into that one field called content. I can't search it until it shows up. So we'll see if it's going to show up. OK, so it's done now. So back over here, if I now search this, if I don't do anything, you'll see, oh, that's not the same. It's not the right storage account. This one has 7 in it. I mapped to the wrong storage account. But that's OK. I still have all these different blogs inside of here. And they're really not that important what's in them. I just want you to see, like, this one is creating a progressive web app, doing something with Kentico and Azure, automating translations, tips for hosting Azure SQL, Azure Search Indexing, Azure Performance Hosting. It doesn't really matter what's in there, because I'm going to search. I just want you to see how it's finding the information inside of it. So if I pick something like Azure Search, well, all but one of them. That's not very exciting. So let me do progressive. How about that? Because only one's there. So now you can do that. And with this, it actually looked at the title, and it looked into the actual content, and it's finding the stuff that's inside of there. But because I mapped that extra field to it, I can actually click it, and it's going to open up the actual file directly from there. So this is a really good way if you had like a bunch of PDFs or something that you wanted to be able to search. You can throw them in an Azure Storage account, just create an index that will go index that however often you want to do it, and then you can get searching, full text searching inside of there, again, without having to be on your machine. Yes?
I was just curious, if you update a document, does it automatically get it the next time it re-indexes? And I guess the correlation on that is that if it re-indexes, does it search everything again, or only the documents that have changed or been added?
I don't know. That's a really good question. I don't know. My indexer, the indexer has a setting that says create or update. which means, oh no, that's the indexer itself. Sorry, no.
Yeah, I know there's a merge or insert only.
I don't really know how Azure, I'd have to ask that question. I don't know the answer to that. That's a great question though. I've never thought about that if it changes. I was actually going to explain another thing that you can do, but it doesn't address what you just asked. So I'll have to try to find that out. I'm not really sure. I'd have to ask them. It seems very inefficient that it would completely re-index everything again. But it's possible that maybe it looks at a modified date, but I don't really know. I'd have to look into that one. As of right now, this indexer is going to run every 5 minutes, but you can use other parts of Azure to get around that to do something a little bit different. You could use something like an Azure Logic app or an Azure function, and one of your Azure functions could have a trigger. And one of the built-in triggers for Azure Functions is to see when a file changes inside of a storage account. Actually, I will address what you said now that I think about it. You can actually point it to a specific container. And anytime something changes in that container, like if you upload a new file, it will fire off your Azure function. Your Azure function could contain the code to then push it into your index and have it re-index it. It's possible that it probably would also fire in that case as well. But I don't know how it does it by default. I'd have to ask about that still. But as you can see, it's really powerful to be able to get this full text out because you don't have to, this isn't your server that's digging through all these files. It's already just going to happen behind the scenes with Azure Search. So 5 minutes left to get through like a few more slides. Let me do that, and then I'll leave a few minutes for any questions real quick. So there's a lot to Azure Search that does a lot. So how much does it cost? It can be expensive, let's put it that way. So I use the free one, which is really good. You can only have one free service per subscription, so that's important, but it's really good to test with. Azure Search starts ratcheting up in the cost that it has, like 10 cents an hour if you want to have a basic. And it really depends on how many indexes you want to have and how big those indexes are. Because again, you could have the same set of data, but maybe multiple indexes on it depending on how you're going to interact with it, which could use up your space. But the idea I try to tell people is search is not really a good solution for a single application. It's really good if multiple things are going to use that data for something else, or multiple applications are going to use the search service, maybe for their own data, but multiple ones. And so you can use the same search service for like all of your applications in your organization or something, because it gets pretty expensive really fast. But you can scale it. It can have partitions, so it can handle more throughput. You can scale it up in the unit so that it actually has more horsepower to run with. I'm not going to get into it because there's a link coming up here. I'm going to jump over this only because I'm running out of time, but there's a lot of reporting that's built into it, things that say how much your search is being hit, how many errors that it's returning, how many no records it's returning, and you can download these BI reports and look at pretty graphs if you're into that kind of thing. But how often your search is being hit, so you know when you might need to scale up at specific times. All that analyzation is already built into it. So I have a bunch of links here, and I'll share this, or you can take a picture of it if you want. But this one in particular right here. So this link is really good because it basically walks you through how to choose the consumption model for what you are trying to do. And it will, how to choose the tier, how to match up the tier to what you want. But this is a lot of just really good links about it. If they have any way for me to share the slide deck, I absolutely will. But I'll also tweet it after today. My Twitter is Bryan_Soltis. You'll see that in a minute. I'll tweet a link to the PDF of this entire presentation too, so you have all the stuff. But that one down at the bottom is really good because it can help guide you. But then everything else is just different documentation and stuff about it, what's on the roadmap, things like that. That being said, this is my information. You can totally hit me up anytime you want to. If you have more questions, please let me know. If you write me, I'll try to find the answer to that. But 2 minutes. Does anybody have any other questions? Yes? Oh, several. Yes?
Is there predefined synonym maps for things like that?
I don't think there's any predefined synonym maps. They're all custom. So you have to make them yourself. Yes. Then I'll come back to you. Right here?
So with that, is there a way to easily set it up so that those types of names would be predefined, or do we have to do it the way that you?
As far as I know, that's the only way to do it. Now, as I was talking to him earlier, they just started integrating in cognitive services. into Azure Search, but I still think it's in preview because I think you can only do it in the South Central US data center in the United States, like one data center, which is normally indicative of it's in preview, in which you can apply cognitive services to the search data. So you can get some like text analytics going on and machine learning if you really got to that point. That you probably could get there eventually, but I don't think it's built in to do it out of the box right now. But I suspect it's coming, or you probably could do it yourself right now if you use the cognitive services piece, if you knew a lot about AI, which I don't, or machine learning. So, you had a question? Yes.
Can you search across multiple indices yet? Or
Not, as far as I know, not yet. I think it's still just one. I haven't verified that recently, but as far as I know, it's still just one index. Yes?
Is there any like user security, right? So like you imagine there's predicates on records for if you have a Azure AD principal or something like that, you can access a subset of things, search across those, or?
I haven't, the only part I've messed with security is like the cores. You can restrict where the requests come from and only reply to, on your service will only reply to requests from like a specific IP or a, like a URL. But I don't know about, once you're in the index, I think you just get whatever data is inside the index. It's possible, I've never looked into that, I don't know. Unfortunately, I don't know the answer to that, I'd have to ask about it. All right, well, hopefully that's how you feel now. And you're all excited. Hopefully you go out and use Azure Search. It's awesome. It's free. Do the free plan. I run all my stuff on the free tier. Oh, I didn't show you this, but it's really not as exciting. But this is my actual site that is running. It's nowhere near as exciting. I don't have anything interesting on there, but under here, so I have Azure Search. And I'm using it. Shockingly enough, I'm using it as well. So, but it's really good. It offloads all your search to something else. And you can do it really easily. So thanks for coming. And if you have any questions, please feel free to reach out to me after. I mean, I'll be glad to answer anything, and I'll try to find the answer to that question and the other ones as well. I'll do the best I can. So, all right, thank you very much.